I know. See black square?
It makes the whole.
There it is. Now it's starting.
Makes the whole hello like just that.
Hello and welcome back to differential
It's
equations.
just a nice long
We are talking
silent
about solving systems of differential equations, the first order, and we are dealing with method of elimination. So we learned how to set them up in the previous section, and now we're going to solve them. So we start by having x prime. Let's just write the system for x minus 3y, and y prime equals to 6x minus 7y. So to solve this system, observe that you have variables, functions x right there, functions x of t and y of t, and that each one has x and a y. Now one has a x prime, the other one has y prime. So what I could do is I could solve this one for x and get the x prime and then equal it to the other one. Do you see that? So if I solve the bottom equation for x and I differentiate, I get x prime equal everything else, but you have x prime equal to everything else on top, and you equal those two. Or I can solve the upper one for y, differentiate that, get y prime equals everything else, and equal it to the second one. It usually is what's more convenient, right? Now both of these are a little bit evil, so tough luck. So solve the bottom one for x. You get 6x is equal to y prime plus 7y. And then you get x equals 1 over 6y prime plus 7 over 6y. And then differentiate and get x prime is equal to 1 over 6y double prime plus 7 over 6y prime. And now equal to equation number 1. So equation number 1, so what do I have? From the bottom one I have 1/6 y double prime plus 7 over 6 y prime is equal to 4x minus 3y. All right, now time to cry about this x over here because everything else in terms of y. But look at this one. You see that? Plug it in. Yeah. Plug in x equals 1 over 6y prime plus 7 over 6y. And we finally have 1 over 6y double prime plus 7 over 6y prime is equal to 4 over 6 is 2/3 y plus 14/3. Oh, it's y prime. 14/3 y plus 7 over 6y, I believe. Let me see. Or maybe it's not good to cancel because they all have over 6. Let's not reduce. Let's just keep them as 4 over 6 y prime and 4/28 over 6 y, and then plus 7 over 6y. That no, I already used 7 over 6. Minus 3y. Wow. There we go. Much better. Look what you have. Second order constant coefficients. Who's happy now? Everyone is happy, right? So we can convert this system eventually into the second order, right? So immediately multiply through by 6 and put everything on the same side, and then we'll combine like terms. So y double prime plus 7y prime minus 4y prime plus, no, minus 28y plus 18y equal to 0. Y double prime plus 3y prime minus 10y equal to 0. Anyone's gonna say woohoo? No? Yeah, that was a real weak yoo-hoo, but that's okay. We have y equals, factor now. So it goes plus 5 and minus 2 equal to 0. So y is equal to negative 5 and y is equal to 2. So y of t is equal to what? Exactly. Now, who asked for the test? To repeat on the test 1? There is your test 1 right there. Cool. We have this. What I'm gonna do for x? Yes. Do not despair. X is equal to this. All we need to do is to plug those e's there, and we got it. There I say in a flash. So x is equal to 1 over 6 y prime plus 7 over 6 y, if I remember well. Was that true? Of course. Of course. Alright, so y prime of t is equal to negative 5c1 e to the negative 5t plus 2c2 e to the 2t. And we plug that here, and it's equal to 1 over 6 times negative 5c1 e to the minus 5t plus 2c2 e to the 2t close parenthesis plus 7 over 6 open parenthesis c1 e negative 5t plus c2 e 2t. Clearly, right? And all we need to do now is collect like terms, and we have our x of t. So what do I have? I have this term here and this term here, which are both e to the negative 5t. So we have, when you work them out together, you have minus 5 over 6 plus 7 over 6. That's 2 over 6, so 1/3 c1 e to the negative 5t. Bueno? And then we have this term with 1/6 and this term with 7 over 6. So we get 2 over 6 c2. We know it's going to be plus e to the 2t over here, c2 as well. Just need to figure out the fraction. So that's 2 over 6 plus 7 over 6, which is 9 over 6, which is 3/2. And if I had my tada special effect, I would use it about now. So now I have my solution for y of t and x of t. That's the general solution. And then if we have initial conditions, we just plug that in real quick and come up with the particular solution. Because why not? Do we have that? Yes, we do. We do have, we are lucky. We are really lucky because we do have these initial conditions. So now, x of 0 is equal to 2, and y of 0 is equal to negative 1. Beautiful. So we can actually enjoy this as well. Let's see how about x. When I plug in 0, this dies. So I have 2 is equal to 1/3 C1 plus 3/2 C2. Right? So that's from x equation. And then when I plug in the other one, I get -1 is equal to C1 plus C2. All right, so this is from y equation. Multiply the top equation by 6, so 2C1 plus 9C2 is equal to 12. And the bottom equation is C1 plus C2 equals to -1. Bottom equation times -2, and we add. So C's die. It's going to be 7C2 equal to 14. Oh, how convenient. C2 equals to 2. And if C2 equals to 2, then C1 must be -3. Well, this is exciting, because now I can write the overall solution, right? The particular solution. 1/3 of C1, so that's a negative e to the -5t plus 2C2, 3e to the 2t, and y of t, so C1 is -3, -3 to the -5t, plus 2e to the 2t. Ta-da! Not a problem, right? Or you can use Mathematica. What do we have? Another 19 minutes. We should be able to squeeze one more. We'll take a 45-second break. Steve has to drink water. And then go recycle the bottle. Gotta walk a little bit, right? Ugh. Stretch. Differential equation, not a problem at all. There we go. I love that it's like 3,000 degrees. That's awesome.
I hate it.
Why?
Oh, I love the cold.
What's wrong with you?
You don't sweat.
Yeah, but you can die.
You could die in the summer too.
Less chance. Just be in the shade. And smell
You're in the
bad.
shade,
In the winter, everything is cold. It's just.
I had to work last summer in like. What? No, with my uncle, I was doing windows inside.
All right, so let's try one more. Let's try to find something interesting. You know what I mean? Ooh. X prime is equal to 2x plus y, and y prime is equal to 2x plus y, x plus 2y minus e to the 2t. Yeah, they don't give us initial condition. Lame. But that's okay. All right, so now we're looking at this problem, and to start it off, you can solve the upper equation for y, because look, it's a single y there, right? To solve for that y, differentiate, equal it with this one. Don't let me hold you up from doing that. So the solution of the problem is e to the... Just kidding. So this time around we'll have non-homogeneous one, right? All right, so try to push past this point.
imagine you like plugging it into the that'd be awesome. That's something. What is what? Oh, he's in it. Yeah, I know. Oh, no. Oh, you can just make your life more fun.
Okay. We only have about 7 minutes, so one more time. This is only the first half of the lecture. The second half with the matrices we're going to take care of next time with the differential operator D. We'll take care of that. It's not going to be an issue. Now let's take a look at this. I have x prime equals to 2x plus y, x double prime. Now I'm picking to solve here for y because of the e to the 2t. So when I solve this one for y, I get this and then differentiate it to create y prime so that I can set these two y prime equations equal to each other. So that's the method of elimination. So now when we set these two equal to each other, we eliminate y prime, and everything is in terms of x now. Now we gain x double prime in the process, move everything to the same side, and now I'm going to distribute and collect like terms, and we are going to get constant coefficients, but this time we are going to have a forcing term. And we just solve with whatever method we have, right? So we have x double prime minus 2x prime minus x minus 2x prime plus 4x is equal to negative e to the 2t. So that's x double prime minus 4x prime plus 3x is equal to negative e to the 2t. So now we solve the homogeneous half first, which is the x double prime. So we have r squared minus 4r plus 3 equals to 0. That factors as r minus 3 minus 1, r minus 3, r minus 1, from where r is 3 and r is 1, which immediately gives us that x is equal, x of t is equal to c1 e to the 3t plus c2 e to the t. Well, now we have the forcing term on the other side. Luckily it's not 3e to the 3t and e to the t, because we would have to suffer longer. This way we can solve it quicker with which method, anyone remembers? Exactly. So variational parameters. I should have written this here so I can fit everything. So we have to differentiate this few times and catch the pattern. So x prime of t is 3c1 e to the 3t plus c2 e to the t. X double prime of t is 9c1 e to the 3t plus c2 e to the t. So we quickly see that xp is of the form a, right? E to the 3t plus, and we can keep c2 e to the t here because that one doesn't change. See, it's always the same. Are we good with this? No one cares? Thank you. So now we have x prime 3a e to the 3t plus c2 e to the t, and double prime equals to 9a e to the 3t plus c2 e to the t, which we plug back in the original equation. Up there. So x prime 9a e to the 3t plus c2 e to the t minus 4 times the prime. This is going to be minus 12a e to the 3t. That was minus 4, right? Minus 4c2 e to the t. And plus 3 times the top one, plus 3a e to the 3t plus 3c2 e to the t equals negative e to the 2t. Awesome. Collect like terms. Nothing to worry about. It's not going to hurt too much. Just a little bit. 9 minus 12 plus 3. Wait, they all canceled. Huh?
They'll cancel out.
Yeah.
Everything cancels.
Yeah, everything cancels.
Zero.
Well, worse. The hell? Take derivative, so that changes. So AC1, A1, 9 minus 12, 3, gone. 1 plus 3 is 4, minus 4 is 0. Yeah, I'll have to figure out what's happening here. So we'll continue this next class when I have to do the second part of this lecture as well. So we'll continue from this point on. I just don't see where is the mistake. This is all good. That's all good. Derivatives which give us the original part. Derivatives of that one plugged in. Yeah, I'll figure out what's wrong here. So this was problem number 8 in the textbook. So we'll finish this next class, and then we'll continue with matrices 5-3, and I think 5-3, 5-4 next class. Okay. And then after that we are jumping to chapter 6 for numerical approximations, Euler's method, Runge-Kutta, and so on.